The Build It, Fix It iMod is a grade 3 science and engineering unit. Teachers in Massachusetts worked with staff at EDC to take a science unit with familiar activities and integrate computational thinking. In this unit, students explore forces in motion and how forces can be transferred through chain reactions. This video will highlight key activities in the unit that help support students' computational thinking and will demonstrate some strategies you could apply to integrate CT into your own activities. I'm Kevin Waterman from EDC. Let's take a look at what students will do and learn in this unit. Students start by experimenting with balls and ramps. They roll several different balls down ramps and across a variety of surfaces, recording data, the distance each ball travels, as they go along. An activity like this may already be part of your curriculum. It primarily allows students to explore the concepts of force and momentum. Some students may have encountered similar activities as early as kindergarten. When done in third grade classrooms, students are often tasked with collecting data and later analyzing it to make conjectures about those concepts. Analyzing and interpreting data is one of the 8 science practices from the Math Science frameworks. It also is a key topic in the computational thinking strand of the Mass Digital Literacy and Computer Science standards. When integrating computational thinking into units, a good place to start is to look at activities where opportunities already exist that are building students' computational thinking. Here, collecting and examining data already existed within the unit, and you can leverage that part of the activity to start having students exercise their computational thinking skills. For instance, one of the DLCS standards in the CT strand calls for students to organize information in different ways to make it more useful or relevant, such as organizing in tables and sorting to show patterns. Students sort and analyze the data to see which ball goes furthest on a particular surface. Having students manipulate the data, especially if they can use digital tools such as a spreadsheet program, directly supports a grade 3 to 5 computational thinking standard about data. By focusing on collecting and manipulating the data, and weaving in the opportunity for students to experience how technology can help them, teachers enhance the existing activity to more directly build their students' computational thinking. And by sorting the data, students can more easily see patterns in the data, which can help them generate conjectures such as, why does a golf ball go further than a ping pong ball on a carpet? In the next part of the unit, students explore chain reactions, sequences of cause and effect connections. Students learn about changes in momentum and apply their learning to a final project where they build their own unique Rube Goldberg machines. In this class, students started with a simpler task of designing a sequence of transfers of momentum to ring a bell without touching it directly. As students develop their solutions, they learn through experimentation and by comparing their solutions with those of their classmates that they can ring their bell in many different ways. The cause and effect chain reactions that students design can be thought of as a visual representation of steps in a simple algorithm. Certain actions must take place in a particular order to reach an intended result. There is a good amount of overlap between engineering practices and computational thinking skills, especially in early elementary grades, when students are building foundational skills. The engineering process of testing setups, having them fail, refining the setup to fix the problem, and testing again is very similar to writing and debugging programs. By using trial and error to redesign and rebuild their Rube Goldberg machines, students are detecting and correcting logical errors in their algorithms throughout the engineering design process. Visit our website to download this and other units for free, and to see tips on integrating computational thinking into other activities.